Hello, IB Math students. Let's review quadratic models. A lot of what you see in this lesson should be review information, but you just might see it written maybe a little differently than you have in the past. So we want to be consistent with the way IB writes equations and formulas and things. So let's just first of all review the difference between the general form, the vertex form, and the factored form of a quadratic equation. But I guess before we should do that, we should fill in this first blank. As you recall, the graph of a quadratic equation is always going to be a parabola. All right, so let's go ahead and start reviewing those equations. So we're going to start with the equation of a quadratic function in general form, and it looks like this. F of x is equal to a times x squared plus bx plus c, where a and b and c are all real numbers, and of course a cannot be equal to 0, otherwise the quadratic term would drop out. Okay, you might recall from your Algebra 1 and Algebra 2 classes that the axis of symmetry, when the equation is written in this form, it can be found by taking the opposite of b over 2a. Remember, the axis of symmetry is a line, so this is the equation of a line. X equals the constant, which you'll find by taking the opposite of b over 2a. To find the vertex of a quadratic equation, or the vertex of the graph of the function, the x value will be the opposite of b over 2a, and then to find the y value of that point, we'll just take f of the opposite of b over 2a. So put that constant into the function, and that will give us the y value of the vertex. All right, you may recall that the vertex is a minimum when you have a parabola that opens upward. That means that the vertex will be a minimum, and that's going to happen whenever the a value in that leading coefficient is positive. And then the vertex would be a maximum when the graph will be upside down. The vertex will be a maximum when that leading coefficient is negative. And then to find the roots or the solutions, we just solve the equation ax squared plus bx plus c equals 0. So the solutions to this equation, in other words, the x values that produce a y for 0 would be the roots. Okay, so that's general form. So now let's look at vertex form. So vertex form of a quadratic equation looks like this. F of x is equal to a times x minus p quantity squared plus q. Now in your Algebra 2 classes, it's likely that your teacher used h and k here. So this is just the IB way of writing the same thing. So a times x minus p quantity squared plus q. To find the axis of symmetry, remember that's a line, it's a vertical line, and it's just going to be x equals p. So to find that axis of symmetry, all you have to look at is p. To find the vertex, it's very simple to find the vertex. That's why this is called vertex form. The vertex is simply found at pq, okay? And then again, the vertex is a minimum when the parabola opens up, and that happens when a is greater than 0. And the vertex is at a maximum when the parabola opens down, and that happens when a is less than 0. Now, from this form, we can't really find the roots or solutions, so we'll just say not applicable for the solutions in vertex form. But then last but not least, let's look at factored form. And factored form looks like this. F of x equals a times x minus k times x minus L. And again, you may have seen different variables in different classes, but this is the way our textbook and the way IB represents it. So to find the axis of symmetry, that's going to be the line x equals, all we need to do is take k plus L and divide it by 2. And that will give you the axis of symmetry when your equation is in factored form. And then this, to find the vertex, that would be the point k plus L divided by 2. That would be the x value. And the reason why we're averaging is these would be the x values where the parabola touches the x-axis. So if we average them, we're going to get the point right in the middle, the x value of the point right in the middle. So that would be the x value of your vertex. And then to find the y value of your vertex, that would be f of k plus L, all divided by 2. Okay, and then again, minimum when a is greater than 0, and that vertex is a maximum when a is less than 0, because the parabola would open down. And then to find the solutions or the roots, that would be at the point k, comma 0, and at the point L, comma 0.